Okay, so I just wanted to make a few brief videos going over some of the things we went over in chapter 1. These will not be as exhaustive as the lectures I did in class, simply because I can't make a video that's an hour and a half long. But they'll cover the basic material, and they'll give you a chance to kind of review things if you have any questions about them. So first, I just wanted to run through the cross product and how we actually calculate it and find it. We remember, if I have, say, two vectors, I'll have one here and one here. The cross product, if I call this, say, u, and this v, the cross product is the vector that's perpendicular to both of those vectors. So this will be u cross v right there. And as far as calculating goes and the definition of it, as we said in class, there are multiple ways to do that. There's multiple ways to define it. And just like with the equation of a line, we have slope-intercept point slope, standard form. You know different equations of a line so that you can solve different types of problems based on the information you're given. There are different definitions of the cross product or different ways of writing it, which you will use based off the type of problem you're solving. For the purposes of this, we just want to use the basic definition of the cross product of two vectors, calculate one of them, and then from there we can actually get some of the other definitions if necessary. So, let's see. Suppose I have a vector u, which is equal to my standard 1, 2, 3. Let vector v be the vector -2, 5, 7, I don't know. I want to find u cross v right there. And hopefully not drop my eraser on myself. The way we do this is to find this, I'm going to need a lot of room, u cross v right here. I create a matrix that's 3 by 3. The top is my standard unit ijk. This is not commutative, so I have to put it in the correct order. U cross v, u goes first, so 1, 2, 3. V goes second, -2, 5, 7. Now I calculate the determinant of that, which will generate my cross product. Meaning, here, to do the first one, I start with I get rid of the row and the column with respect to I. This is going to get messy, so I'm only really going to write this one. Then I do the determinant right here. So I look at that 2 by 2, 2, 3, 5, 7, times I, that corner. Now I subtract, remember the sign switch, this is positive, this is negative. The third one I do will be positive again, they alternate. Now I look at J, I cross out the row and column of J, and I find the determinant of the resulting 2 by 2, which is 1, 3, -2, 7. That gets multiplied by J. Plus, again, plus minus plus. Now I look at K, I cross out the row and column for K, I'm left with 1, 2, -2, 5. That gets multiplied by K. Now find the determinants. In this case, you all know the determinant AD minus BC. 7 times 2 is 14, minus 5 times 3 is 15. So that's -1, I, minus 7 times 1 is 7, -2 times 3 is -6. 7 minus -6 is 7 plus 6, which is 13, J. 5 times 1 is 5, -2 times 2 is -4. 5 minus -4 is 5 plus 4, which is 9, K. That's my cross product, which of course, if I want, I can then write as -1, -13, 9. And again, I'm not going to graph this, but the idea is, if I graphed vector u and I graphed vector v, this vector, u cross v, would be perpendicular to both of those. A lot of times we end up calculating the magnitude of the cross product, but in this case, as long as I do this, I'll just use this vector right here. But if I want to find the magnitude of u cross v, well, that's just the magnitude of this vector, which is just the three-dimensional distance formula. Square the first, square the second, square the third, add them up, square root. So -1 squared is 1, plus -13 squared is 169, plus 9 squared is 81. 169 and 1 is 170, and 81, 15, so that's 251. and it's root 251. And now we have a nice, simple way to actually calculate the cross product. And again, you do need to know how to do this. There are a few other ways that we can define the cross product and the magnitude of the cross product. Those are in your book, those formulas, and we did go over them in class. But as long as I have this definition and vectors, I can generate the cross product, and then if necessary, I can find the magnitude. And I'll be good to go from there.